Now in your lab kit, you should have a nice metal slinky. Nice one like this. It's just like the ones you buy in the toy store. And the first thing I want you to do is get this out. Mine has been taped to a big solid box at one end, but for this you can just hold both ends. And we're going to make a wave disturbance and watch it go. So here we go. To make a wave disturbance, all I do is move one end in and out again pretty fast, and that makes a pulse that you can see travel down the slinky. There we go again and again. Okay, so they go down, they travel through the slinky, and as they travel, this pulse propagates. Now notice that the pieces of slinky are not moving very much. They jiggle back and forth a little bit, but nowhere near as much as the wave disturbances. It starts over here and it goes all the way down here. It goes a long ways. None of the slinky is doing that. The motion is all the disturbance. It is not the medium. We can easily figure out what the velocity is with a stopwatch and a ruler. Here's my ruler. It's just a yardstick. And if I measure the distance from the end here down to where my hand is, that's about 36 plus 8, 44 inches. How long does it take a pulse to go from my hand to the box? Well, we can do that with the stopwatch. I'm going to hit start when I make the pulse and hit the same button again when it gets to there. And we'll do it 3 times just to be sure. So here we go. 1. That was 0.8 seconds. 2, also 0.8 seconds. And also 0.8. So I get 0.8 seconds to go from here to here. That's 44 inches. We can use those to find out what's the velocity of the wave. V wave is 44 inches divided by 0.8 seconds. We can turn that into metric, and then we'll have a velocity in meters per second. Okay, it turns out that if you have one kind of medium like this slinky, and it runs into another kind of medium like the box, which is radically different, then you will get a bounce wave back again. So the wave disturbance will go this way, then it will bounce off the end and come back. Now as it goes, it gets smaller and smaller, mostly due to friction with the tabletop. This is clearly diminishing the wave as it goes. But if I make a big one, we should be able to see a wave go down through the slinky, bounce off the far end, and come back again. And here we go. I'll do it again. Some of those were clearer than others, but I could see a bounce 2 or 3 times. I want you to try this until you can see a nice bounce and convince yourself that it really happens. This is part of being a wave, is that waves bounce off boundaries, they reflect. We'll be using this over and over when we get to something like optics. We talk a lot about waves reflecting and exactly what happens when they hit a boundary. Okay, that's it for compression waves. The next thing we're going to do is have a look at a string wave, a standing string wave, and I'm going to have to set up some more stuff for that, so we'll be right back.